Namaste students. Today's concept is computational thinking for grade 8. Chapter 1, a square and a cube. Here we have our first question. In the following grid, all circles follow the same theme. What will be the value of a plus b? Let's find the values of a and b first. For that, we'll have to understand the pattern in the grid. I notice a pattern. Your 4 square is 16, 3 square is 9, sum of 16 and 9 is 25. So let's cross verify the pattern. And here we have 2 square which is 4, and 3 square which is 9, 4 plus 9 which is 13. Great. I believe we found the pattern. Your 5 square is 25, 9 square is 81, and the sum of 2 is 106. In that case, 9 square is 81, so 117 minus 81, that's 36, and the square root of 36 gonna be 6, which should be the value of b. On the other side, 6 square, which is 36, 85 minus 36, which is 49, and the square root of 49 is 7, will leave the value of a. So as per the question, the value of a plus b, a is 7, b is 6, so sum of which is 13. In that case, we go with option C. Great. Moving on to the next question. Sam writes a list of natural numbers. The list has 3 perfect cubes and 3 perfect squares. So let's list out the perfect squares. 1, 4, 9, 16, 1, 4, 9, 16, 25, 36, 49, 64, 81, and obviously the next number would be 100. Okay, great. The cubes, let me say 1, 8, 27, 64, 125, 216, and just goes on. Okay, if no number in the list has more than 2 digits, okay, no number in the list has more than 2 digits, okay, so I don't think so we can note down 125 and 216 as the numbers are of 3 digits. Okay, what is the minimum number of distinct numbers he must have written? Minimum number of numbers, actually one, it's both the perfect square and a cube, so one number will do for both the cases. And I believe 64 again, which is a perfect cube as well as a perfect square. Then let us choose any 2 numbers. Let me say 4 and 8. So minimum 4 numbers are must, so that he can have 3 cubes. At the same time, he can have 3 squares. Hope we understood the concept. Then minimum 4 numbers. Great. Let's move on to the next question. If AB is a 2-digit number, whose cube is in the form of a 4-digit number. Great. Ends with C such that A is less than C and C is less than B. Okay. A, B, a 2-digit number. Let me say like 1, 0. And they have asked for a cube. So 10 cube, obviously it's going to be 1000. It should end with C. Here it is B and here it's C. And they have mentioned that C is actually less than B. Okay, in that case, I believe we can't consider this 10. Okay, let me list out all the cubes. Okay, 10 cube is 1000, 11 cube, so on so. And as you see here, 22 cube is a 5-digit number. But actually, our discussion is all about 4-digit numbers. So we stop with 21 cube. And let's note down the values of A, B, and C. As you see, A is less than C and C is less than B. Let me note down the A value. It's all like 1, 1, 1, 1, 1, 1, except for the last two numbers, which is 2. And B value is actually like, it's like 0, 1, 2, 3, single digit natural numbers, 4, 5, 6, 7, 8, 9, and again 0, 1. Great. So let's note down the C value now. Okay, let me first highlight the C value. It's here 0, 1, 8, 7, 4, 5, 6, 3, 2, 9, 0, 1. Okay, in this case, actually, it's ending with 1 and here with 1. So B and C are equal. We delete them, eliminate them. Here B and C are zeros. Here it's 9. Yeah, here we can make a note. The value of B is 8. The value of C is 2, which is like 2 less than 8. Okay. At the same time, here we have 7. B is 7, where the C value is actually 3. Okay, on the other side, they are equal. Here they are equal, they are equal. And here actually like B is smaller than C, so we eliminate it. And here B is again smaller than C, we eliminate. And this is equal, this is equal. Oh, great. So we have two such numbers which satisfies the given condition. AB, a 2-digit number, and the cube is of 4 digits, where it ends with C, and B is greater than C. B is greater than C. B is greater than C. At the same time, here it's the same again. B is greater than C. So we have two such numbers. So I go with option A. Great. Moving on to the next question, we have 56 times K is a perfect cube. K is a natural number. What would be the smallest possible value of K? Smallest possible value of K. 56 times K. So let's factorize 56 first. I go with 8 times 7, which is actually 2 cube times 7. So obviously K need to be 7 square, which is nothing but 49. Got it. Great. So that we have 2 cubes, 7 cube, which can be written as 14 cube. So K must be 49, the smallest possible value for the whole number, the product to be a perfect cube. Great. Let's move on to the next question. And the next question. Oh, wait a minute. We have some symbols and numbers. How are we gonna connect this? Okay, 16 and the shape is a square. Oh, I get. 16 square is 256. At the same time, 19 square is 361. Great. I believe this is a cube, which is nothing but 15 cube. We have 3375. At the same time, 11 cube is 1331. Great. Then 14 square is that 196, and 12 cube, it's 1728. Let's add them up as there is a positive symbol here. Okay, 1728, which is 12 cube, and 196, which is 14 square. I have 1924, and I go with option C. Great students, hope today's session was useful. Let's meet in the next video. Thank you.